Hello scholars, welcome back to another video. This is for lesson 28. We are on pages 40 to 42. Of course, we're going to start by looking through the questions. So here we have lines 45 through 50. Look through that. That is for question number 2. Positive and negative reactions is what we're looking for here. So just wrote positive and negative. Then over here, there's something more complex. And then our short response is about robots getting a personality. So I'm just going to jot that down at the top. So that we can keep track. And then number 1, 13 through 19. And there is a connection that we are looking for. So again, we're looking, what do they have in common, or what's their similarity? So here we go. Cool Jobs, Wide World of Robots by Roberta Kwok, Science News for Kids Online. When you think of robots, you might think of something like WALL-E, a machine designed to perform boring tasks, such as compacting trash. But engineers today are making robots that can do much more interesting jobs. Robots shaped like snakes could one day search for victims after an earthquake or help doctors perform surgeries. Underwater robots might be able to lead fish away from environmental disasters. And human-like robots could help people with diseases or physical disabilities. Engineers who build and program robots have fascinating jobs. These researchers tinker with machines in the lab and write computer software to control these devices. They're the best toys out there, says Howie Chosette at Carnegie Mellon University in Pittsburgh. Chosette is a roboticist, a person who designs, builds, or programs robots. Robots with a personality. Matches up with what our short response is. When Maya Matarik was in high school, she wrote a computer program that talked back to a person. The user could type a message into the computer and the program would display a reply. Now a roboticist at the University of Southern California in Los Angeles, Matarik is leading a team that programs machines called socially assistive robots. These devices can talk, make gestures, and move around. Matarik wants her team's robots to help people who have diseases or physical disabilities. For example, a person with Alzheimer's disease, which causes problems with memory and brain function, might need help with mental exercises. A person trying to regain the use of an arm after a stroke might need encouragement to keep doing helpful exercises. Because there are not enough people to provide all of the help that is needed, says Matarik, technology has to step in. In one study, Matarik's team tested a robot with people recovering from a stroke. A stroke is caused by a broken blood vessel in the brain, or a blood clot that prevents blood from flowing to the brain. Small regions of cells die during a stroke. So afterward, part of the body, like an arm, may become weak or numb. A patient has to keep exercising that arm to recover. Those exercises can be difficult and unpleasant, however. Matarik and her colleagues programmed a knee-high robot to ask a patient to perform an exercise and then monitor the patient's movements. If the person actively used his or her arm, this robot would say encouraging things. The team tested the robot with 6 people actually recovering from a stroke. Patients tended to perform their exercises longer and follow instructions better when the robot was present than with no prompting. Next, the researchers tested whether the robot's personality affected how people responded to it. The robot could be directed to move in close, speak loudly, and make forceful statements such as, "You can do it!" Other times, the researchers would program the robot to ask more shyly. At these times, the robot kept a bit of a distance and softly offered gentle suggestions such as, "I know it's hard, but remember it's for your own good." In this study, healthy adults performed exercises using their weaker hand. The tasks were similar to those done by patients working to recover from a stroke, such as moving pencils or turning newspaper pages. People practiced their task longer when the robot's personality was similar to their own, the team found. Matarik is also working on robots to help children with brain problems known as autism spectrum disorders. Children with these conditions have trouble communicating and interacting with people. Matarik hopes a robot might help these kids practice their social skills. And one big advantage of a robot over people, it never gets tired or frustrated or angry. The team designed and programmed a 3-foot-tall, human-like robot called Bandit that can make noises, move around, wave, and blow bubbles. In one study, the researchers watched how 8 children with autism spectrum disorders responded to Bandit. Some kids seemed to like the device. They talked to the robot, played with it, and tried to get the machine to follow them. Other kids seemed uncomfortable, perhaps because of the sounds made by Bandit's motors. These kids backed away from the robots and stayed close to their parent or against a wall. Matterik's team is now working on improving Bandit so that the robot can tell if a child is having a good reaction or a negative one. For example, if the child is hiding against the wall, Bandit might back away, make an encouraging noise, or just shut down its motors. Matterik and Chosette are just a few of the many engineers working on robots today. Whether you want to create robots that explore the ocean, travel to outer space, help elderly people, or perform medical procedures, there's just no limit to what we can do in this field, says Matterik. So you guys are completing questions 1 through 4 and also the short response. Our short response is actually pretty simple. It says, why is giving robots a personality an important part of developing socially assisted robots? And we annotated that already. Use 2 details from the article to support your response. Have a lovely day, stay safe, and make good choices. Bye!